Welcome to the seventh session on fundamentals of computer. I'm Manibhushan D'Souza, and in today's class we are going to look at Boolean algebra. So let's look at what is Boolean algebra. Today we are going to just look at some of the definitions of Boolean algebra. This is in particular towards the algebra, not specific to the Boolean algebra. So let's start with the definition of a set and the elements of a set. We know very well a set is nothing but it's a collection of elements. So you can take any collection of elements, and if you get the collection of elements, they form the set. So we are familiar with that. Now we use the notation belongs to, this epsilon notation, to say that X is an element that belongs to the set ES. In the same way, we use does not belongs to, this epsilon with a dash, indicating that the element does not belong to a particular set. Also, the elements of the particular set is shown in the flower bracket, so that you can notice over here. So A inside the flower bracket 1, 2, 3, 4 indicates that there exists a set that contains the elements like 1, 2, 3 and 4 and so on and so forth. So this is how the notation is used in the algebra. So let's now define a binary operator. Now first thing we will have to notice over here is it's a binary. Binary means bi means 2. So it is an operator that operates on 2 operand. That is why it's called as binary. So binary means 2. That's the first thing you must understand. So binary operator that is defined on a set S is a rule. So operator is nothing but it is a rule that does something. So whenever we say that there is an operator, like there is a plus operator, there is a minus operator, there is a division operator, there is a multiplication operator, we know that from our childhood we have learned that how to add, there is a rule that we need to follow. How to subtract, there is a rule we need to follow. In the same way, whenever we say, in general, whenever we say that there is a binary operator, what we are saying is you need to follow a rule in order to apply that particular operator. Now, what does the rule says in general? So the rule says is that if you have a set like this, and if you have two elements x and y, and if you apply a binary operator on these two elements, so if you apply a binary operator on these two elements, by, because it is 2, that's why we say binary. Okay, it could be ternary if you have 3 elements, unary if you have 1 element. Now we are talking about binary, that's why we need 2 elements. Take 2 elements and apply a binary operator, so any binary operator, and what must be the result? Result must be an element that belongs to this set. So that's what is required. This is also called as a closure. So if you take 2 elements, any 2 elements from the given set, so if you take 2 elements x and y, and if you apply a binary operator, the result must be one more element that belongs to that particular set. So in that case, we say that this is a binary operator. And one other important thing, like what we have seen in the functions, that the operation must take you to a unique element. That's a very important thing. Now we are all familiar with the functions, that's why I'm not searching much on it. So when you apply a binary operator on 2 elements, you must get a unique element that must belong to the same set. Okay. Let's look at a simple example over here. Suppose if you take two elements, say A and B, take two elements A and B, and let's assume that you have a binary operator star. If you apply A star B, you are going to get a element C. Then very important thing that C must also belong to the same set. That's a important thing. So star is a binary operator which specifies that a rule. So what is the rule? That if you take two elements A and B, also if in case of if you want to represent in the form of a set inside a circular bracket, you put A comma B is a set. Okay. Now you apply an element, apply a binary operator, then it results in the value, unique value C. What is important? Important thing is all of them must belong to the same set. Suppose you have A, B, C, okay, and if you apply an element, if you apply a binary operator star, and if AB belongs to this set, but the C that what you obtained does not belong to this set, so C is obtained somewhere else, then it is not a binary operator. Now let's look at one other definition, and that definition is called as a postulate. So what's the meaning of saying postulates? So postulates are nothing but the basic assumption which are assumed to be true. So we assume that some things are true, and then based on that thing we deduce some other rules, theorem or properties. So some basic assumption that we say that let there be something, and then we will derive something out of it. So if you have studied about physics or something, let there be an atom, and then you start deriving something in chemistry or any other rules that we see. So same thing, we have some basic assumption, based on that we derive something, and that these basic assumptions are called as postulates. Now postulates of a general structure, so let's look at them. Now whenever we talk about in general about the general structure, general postulates of algebraic structures, there are altogether 5 plus 1, so totally 6 will be there. So let's look at each and every one of them. First one is the closure. So what's the meaning of saying closure? It is closed. A set is closed. That is what is the meaning of saying that thing. So we say a set is closed. So whatever you do, you will not be able to go outside this set. So whichever operator you apply, if this operator does not take you outside this set, so you stay within the boundaries of this particular set, then we say that the set is closed. So it is like if you everybody all of you are sitting inside the class and somebody closes the door from the outside, then you are closed inside that room, you cannot come out of that room. So we say you are closed in terms of algebra, we say that it is a closure. Okay, so what is the meaning of saying closure? A set S is closed with respect to a binary operator if for every pair of element of S, the binary operator specifies a rules obtaining the unique element of S. So when you look at this mathematically, you may not get the head and tail out of it, but the rule is very simple. So what does that rule simply says? If you take any set over here, and if there are elements, if you take any two random elements, let me take a x and y, and if you apply a binary operator on it, you get some element. Let's say you get an element p that also belongs to the same set. So it will take you to unique element within the same set. It won't take you outside the set. Suppose if you apply a binary operator on these two elements, and suppose if you get a element say k which is outside this set, So this K is outside this set. Then we say that this is not closed. This set is not closed because you can go out of this particular set. So it isn't that somebody has locked you inside the room and somehow magically you can go out of this room without opening the door or without opening anything. So then it say that you are not closed. If you can go out, maybe using some magic you are going out, then that means that room is not closed. You can go out from that room. Somewhere else you can go. Okay, let's look at a simple example over here. Let's take the natural numbers. We know very well natural number starts from 1, 2, 3, 4 and so on and so forth. Natural number is closed with respect to the binary operator. So what is the meaning of that? You take any two binary elements. Say I take an element. Let me start over again. So let me have a binary operator. Let me say I take the element 1 and 3. If I add them, binary operator that I am talking about is plus. If I add 1 plus 3, what is the answer I am going to get? 1 plus 3 is 4. What is this 4? It is again a natural number. So if you take any two natural number and add them, the next number that you are going to get is a binary, it's a natural number itself. So take a simplest example. Randomly I take number 24 plus 5. What is the answer? 29. Now I am not saying that you don't know the mathematics, but what is it? 24 is a natural number. It's a non-negative number. 5 is a natural number. It's a non-negative number. 29 is a natural number. So that means you are inside the natural number, and when you applied this plus, you are still inside the natural number. So you are not going outside the natural numbers. That means to say that this particular operator, that is binary operator plus, is closed with respect to the binary operator, that is the set. What is this set? Set of natural numbers is closed with respect to the binary operator. So if you take two elements, any two elements a and b for that matter, which are the elements of a natural number, and if you apply the plus operator, if you get one more element c, that c will be again a natural number, and that's why we say that it is closed. The set of natural numbers are closed with respect to plus operator. Now take the other one. What about the minus operator? So is it closed? Take two element 2 and minus 3. 2 minus 3. Again 2 is a positive number which is non-zero positive integer which is the natural number. 3 is also non-zero positive number, that is integer number, which is again a natural number. Now when you apply the negative over here, so 2 minus 3 is minus 1. Now we know very well set of natural numbers are the numbers starting from 1, 2, 3, 4, all the positive integers excluding the 0 are natural numbers. Now we get a number minus 1 which does not belong to the set of natural numbers. So what is the conclusion? Conclusion is the binary operator minus or the negation is not closed with respect to in natural numbers. So with in terms of natural number, the minus or the subtraction operator is not closed. Now let's look at the second example, the second postulate. The second postulate is an associative rule. Now associating is joining. So you associate somebody with that. So whenever we say that Sachin Tendulkar, he is associated with cricket. Okay, Shah Rukh Khan, he is associated with the movies. So association is you are joining something. So here we have the binary operator. We are talking about binary operator. Now you can associate them in any way you want it. Okay. So for example, let's assume that you have three elements x, y and z. Now you can associate x and y together first and then apply the z, or you can apply the y and z first and then apply the x for them. So you can associate it with any way you want it. So you take the operation, these two operations first, then the next operation, or you take these two operations, x and z operation first, and then the x. In any case, you must get the same answer. So if you get the same answer, that means to say that they are associative. So you can associate them, you can combine them in any way you want it, but still you are able to get the result. Next one is commutative. Now like associative, this is exactly like an associative. However, it is between the two elements. When we say associative, you need three elements because you combine two and then the third one. Whereas here you combine only two. So if there is a binary operator star, it is called as associative. If you interchange the elements, you will get the same answer. That means to say that if you take x first and y, so you take x and then apply the operator star and then y, or if you apply y star x, you must get the same answer. So let's look at this example. So 2 plus 3 is same as 3 plus 2. But is it true in terms of minus? 2 minus 3, is it the same as 3 minus 2? The answer is no. So 2 minus 3 is minus 1. What about this one? This is plus 1. They are not same. So we say that minus is not commutative. So if you change the order, you get a different answer altogether. Then we say that they are non-commutative. Let's look at the fourth property, and the fourth property is the identity. So identity is one element that gives you the identity. So the answer is, how can you identify yourself? Suppose if you don't know who you are, what are you going to do? The simplest answer is you stand in front of a mirror and you will see yourself. So that's the same thing. Okay, so mirror is your identity. When you stand in front of mirror, you see yourself. So if any element within the set, suppose you have a set here, okay, with the many elements x, y, z and so on. Now if any elements has one question in its mind, so if x has a question in its mind, who am I? If x asks that question, or if y asks, who am I? If that question is asked, what you are going to say? You stand in front of a mirror and you will see yourself. So that's what you are going to say, is it not? So if somebody says, I don't know who am I, then you say, go and stand in front of a mirror, you will see yourself. That is what, this is who you are. Okay, same thing, if x asks the question, okay, who am I? What are you going to do? Then you will have to find one element. Here, you can't find a mirror here because I am not talking about the real life here. We are talking about algebra. So you need to find some element E in such a way that if x stand in front of that E instead of mirror, if x, remember that E must belong to this set itself. It cannot be outside. So if the x stands in front of E, then it will find its own reflection back. So that's simple as that. So if you stand in front of a mirror, you will see your own reflection. In the same way, if x stands in front of E, that is called as an identity element, it finds itself back. So that's the idea. So how do we express that in terms of mathematical equation? So if x asks yourself, if x is an element that belongs to the set yes, and if x comes to you and say that, who am I? Then what are you going to say? You go and stand in front of this element. Which is this element? Identity element. And if you stand in front of the identity element, you will find yourself. So E star x is x, or x star E. Remember, you stand in front of the mirror, or somebody keeps the mirror in front of you. It is one and the same. You are going to see yourself. So if E star X or X star E, so whether you start with the E star X or X star E, both of them will return back the X itself. Now let's look at the real life scenario. Now suppose if you have set of integers, integer you know very well, integer contains positive and negative numbers. Who is the identity? So in terms of integer, identity is this 0. So 0 is the identity in terms of the plus operator. So if you take the operator plus operator, 0 is the identity. Remember, so for example, you take any element for that matter. So plus is an operator. 1 plus 0, what is the answer? 1 plus 0 is 1. 2 plus 0 is 2. So 2 wants to know who am I. So you take a binary operator plus and you ask them to stand in front of an identity element. And who is this identity element? In our case is 0. So 2 plus identity element is 0. 2 plus 0, you know very well, is 2. What about minus 2? Minus 2 plus 0 is again minus 2. That is not a difference. So you find yourself back. It's like your mirror reflection. You are going to get your mirror reflection. Remember, 0 is not the identity in terms of multiplication. So don't take it to this one. Suppose if you have element 2 and if you multiply it with the 0, you will not get 2. You get 0. I am not talking about that. So 0 is the identity. And you get back the 0 itself. You should get 2, not the 0. So which is the identity element? So identity element in this case is 1. 2 into 1 in terms of multiplication, 2 into 1 is 2. Minus 2 into 1 is minus 2. So remember, the multiplication identity is 1. The addition identity is 0. So there will be different elements that can act as the identity. It is not the identity. E is not common for all the operator. The identity depends on the operator that you are using. Now let's go to the next one, and that is the inverse. Suppose there is an identity element, then you will find an inverse element. If there is no identity element, you won't find a inverse. So if the set is having an identity element E with respect to a binary operator star, then we will say that there is a inverse for any element X that belongs to the set ES. So what is that inverse element? You take that element, suppose you have a element X and you have some operator, okay, some I am going to call that operator as phi, and there is a inverse element X star, let's say X bar, if you X dash, you see that. Now if you apply this operator phi on it, you must get back the identity. So that's the idea. So you must get back the identity. If you do that, you say that there exists a inverse. Okay. So if you take a element for a element X, there exists a element Y in such a way that X star Y, you are going to get the inverse. Now we know very well the X star Y, you are going to get the identity. We know that the identity with respect to the positive, that is plus operator, is 0. Now which is this element that can give you the 0? Now you know very well. So if you have an element A, then who is the inverse of A? Inverse of A is minus A. Because if you add A and minus A, you are going to get the identity element. So that's the idea. Okay. So you take any element 5, okay, and you know positive identity is 0. How can I get 0? 5 minus plus of minus 5. Remember, this is minus 5. It is not a minus. I'm not subtracting. I'm adding 5 with minus 5. So what I must get is the identity. So we say that minus 5 is the inverse of that. Okay, in terms of multiplication, what is the identity? So we know very well in terms of multiplication, identity is 1. Okay, so how can I get it? If 5 is an element, how can I get the answer as 1? So if you multiply 1 over 5, 5 into 1 over 5, then the answer is answer is 1. So you get that identity. Okay, what about minus 5? So minus 5, what is the inverse of minus 5 into, so I am using the multiplication operator, into 1 over minus 5. So minus into minus is plus, so you get the identity element 1 again. So 1 over that element forms the identity. Now if you find a two operators which satisfy all the 5 conditions, which are those 5 postulates. First one is the closure, next one is the associative law, third one is the commutative law, fourth one is the identity law, fifth one is the inverse law. If you find two operators that satisfy all these 5 postulates, then we can define a distributive law. So distributive law is based on two binary operators, let's say star and dot. Okay, so if there are two operators star and dot, then you can say that they can be distributed if you have the dot operator first, x dot y dot z, and then you apply the star. Instead of that, you can apply star with the first element. Okay, so star with the first element and the star with the next set of elements, and then combine them with the dot. So you apply this with this, so x into x star y and x star z separated by dot. So you are, in other words, you are distributing them. So that's the idea. So you distribute, it's like you distribute the load between the two operators. Okay, now let's talk about one other definition that we need to know, and that is called as a field. A field is a set of elements together with two binary operators, each having the properties 1 to 5. That's what I've told you. So there are 5 postulates that we have seen, and both operators combine to give the property 6. So you have two operators that satisfy the first 5 condition, and together they satisfy the 6th condition. Then we say that this is a field. Okay. For example, in terms of real numbers, so real numbers are both fractions and whole numbers. So if the operators plus and dot are fields. Okay, so for example, let's look at the example over here. So you know very well the plus operator, that is nothing but it's addition, and additive identity, we know that it is 0. Additive inverse is the subtraction. Binary operation, you know very well, in terms of the binary multiplication, dot operator, the multiplicative identity is 1, and if the element is not 0, then the inverse is 1 over that element. Okay, and we know very well, if you what did I say here is the positive number satisfy all the 5, the positive operator, the positive operator satisfy all the 5 postulates. The multiplication also satisfy all the 5 postulates. Let me again remind you what are these postulates. So these postulates are, first one is the closure, second one is the associative law, third one is the commutative law, fourth one is the identity law, and fifth one is the inverse law. Using this, we apply the distributive law. Suppose here the plus operator satisfies the first 5 postulate, Multiplication also satisfies the first 5 postulate, and we know very well A dot B plus C is nothing but A dot B, that is A into B plus A into C. So that means it satisfies the distributive law. So we say that it's a field. These two forms the field. That's all in this class. Thank you for your interest. We will meet again in the next class. Thank you.